In the summer of 2019, divers near Lake Winnipeg noticed something strange. The lake bed, once carpeted in sharp-edged zebra mussels, was clearing, not by chemicals, not by nets, not by any program Canada had funded. For over a decade, the government had spent hundreds of millions of dollars trying to stop these mussels from spreading. Boats were inspected, lakes were quarantined, warnings were posted at every dock from Ontario to Manitoba. And still, the mussels kept multiplying. Then, without warning, in certain lakes, their numbers began to fall. No new chemical had been introduced. No new law had been passed. Something else was happening beneath the surface. Researchers pulled samples and found bite marks on shells that didn't match anything in their control data. A wildlife biologist working the shoreline that season would later say the pattern reminded him of something he'd only read about in old fisheries reports. Something small, something overlooked, something that may have been quietly rewriting the rules of an ecological disaster that had cost a nation nearly $500 million to fight. Lake Winnipeg is massive, bigger than some countries. For years, it had one silent enemy hiding beneath its waves. Zebra mussels first appeared in Canadian waters in the 1980s, likely carried in the ballast tanks of ships from Europe. By the 2000s, they were everywhere. They clung to boat hulls. They clogged water intake pipes. They coated docks, anchors, and rocks in razor-sharp shells. A single female mussel can release up to 1 million eggs in one season. Multiply that across thousands of lakes, and the math becomes terrifying. Local fishermen were the first to notice the damage. Nets came up shredded. Boots got sliced open on shorelines that used to be safe to walk barefoot. One rancher near the lake said he stopped letting his kids swim near the dock. The cuts got infected too easily. Government agencies scrambled to respond. Boat inspection stations went up at nearly every provincial border. Signs read, "Clean, drain, dry." But the mussels kept spreading anyway. Hitching rides on wet gear, live wells, even fishing line. By 2015, officials estimated damages and control costs were climbing toward staggering levels. Water treatment plants had to grind through mussel-clogged pipes. Power stations spent extra millions just keeping cooling systems clear. And still, nothing seemed to slow them down. Then, in a handful of lakes, something changed. Mussel populations that had exploded for a decade suddenly began shrinking. No agency had ordered a new treatment. No funding had been released for a new chemical program. Something was already living in those waters, and it had been there far longer than anyone realized. A fisheries biologist named Daniel Osei was the first to take the reports seriously. He had spent years tracking invasive species across the Great Lakes Basin. But this pattern didn't match anything in his files. Mussel die-offs were supposed to be gradual, tied to water temperature or oxygen levels. This was different. This was fast. He pulled samples from the lake bed near Selkirk, Manitoba, and found something strange. Empty shells, cracked open in a specific way. Not crushed, not decayed. Opened. He brought the samples to a lab in Winnipeg, hoping for a simple answer. What he got instead raised more questions than it answered. The cracks matched a feeding pattern used by a specific freshwater predator, one rarely seen in numbers large enough to matter. A predator most people had written off as ecologically insignificant. Osei ordered a wider survey of the lake, and results started arriving within weeks. In every location where mussel numbers had dropped, this same species was showing up in unusually high densities, but that raised an unsettling problem. This creature had lived in Canadian lakes for centuries. Why now? Why, after all these years, would it suddenly start hunting zebra mussels at a scale large enough to matter? A local ranger who had worked the shoreline for over 20 years told Osei something that stuck with him. He said the lake had felt different that year, quieter in some places and strangely active in others. Osei didn't believe in gut feelings, but standing on that dock, looking at a bucket full of cracked shells, he couldn't shake the feeling that something bigger was unfolding beneath the surface, something he didn't yet understand. Osei needed more than shells and guesses. He needed proof. So he assembled a small team and set traps across 6 sites along the lake's western shore. Within 3 days, the results came back, and they were larger than expected. Freshwater drum, a native fish common, unremarkable, often ignored by anglers and researchers alike. For decades, nobody had studied it closely. It wasn't a game fish. It wasn't endangered. It wasn't interesting. But the drum caught in Osei's traps told a different story. Their stomachs were packed with crushed mussel shells. Not a few, dozens per fish. One rancher who had fished the lake his whole life said he'd seen drum before, but never in these numbers. He said it looked like the lake was restocking itself. Osei ran the numbers, and the picture got stranger. Drum populations in these specific zones had tripled over just a few years. But why? Nothing had been introduced. No stocking program existed for this species. Something had shifted in the ecosystem itself, giving the drum a reason to multiply. Then came the detail that changed everything. When Osei cross-referenced water samples with fish population data, he noticed the drum surges weren't random. They were clustered in the exact areas where zebra mussel density had spiked years earlier. It was as if the mussels themselves had built the trap that would eventually destroy them. Osei sat with that thought for a long moment, because if he was right, the answer to Canada's $400 million mussel crisis wasn't a chemical, a policy, or a piece of legislation. It was a fish nobody had bothered to study, and somewhere in that realization was a warning, just as important as the discovery itself. To understand the mechanism, Osei had to go back to the mussels themselves. Zebra mussels filter water at an extraordinary rate. A single one can clean over 1 liter a day, pulling in algae, plankton, and organic particles. At first, this seemed like the problem. Clearer water meant fewer nutrients for native species, and that had worried scientists for years. But there was a side effect nobody had mapped closely. That same filtering process concentrated food energy directly onto the lake bed in dense mussel beds packed together by the millions. For most native fish, that didn't matter. Their mouths weren't built to crack open mussel shells. But freshwater drum have something unusual. Thick, flattened pharyngeal teeth deep in their throat, built specifically for crushing hard shells, a trait that had existed in the species for thousands of years, largely unused, because there had never been this much shellfish to eat. Osei described the moment he understood this as unsettling in a way he hadn't expected. The invader hadn't just introduced itself into the ecosystem, it had reshaped it. And in doing so, it triggered a response from a species that had been waiting, unnoticed, for the right conditions. But one detail kept bothering him. Not every lake showed this recovery. Some, with nearly identical mussel densities, showed no drum surge at all. The pattern wasn't universal. Something else had to be present for this natural correction to work. Osei realized that if he could identify that missing variable, Canada might be able to replicate this solution deliberately. In lakes still suffering under the full weight of the infestation, the only question left was whether that variable could be controlled at all, or whether nature had simply gotten lucky. The missing variable turned out to be depth. Drum thrive in shallow, warmer zones, close to shore, where mussels often cluster thickest. In deeper, colder lakes, the fish rarely ventured far enough to make a difference. Osei's team confirmed it by comparing a dozen more sites across Manitoba and Ontario. Every lake with a strong recovery shared the same shallow, mussel-dense shoreline conditions. It wasn't luck. It was a specific, repeatable set of circumstances, one that could potentially be encouraged rather than left to chance. Provincial wildlife agencies took notice. Instead of pouring more money into chemical treatments, some began exploring habitat adjustments that favored drum populations in vulnerable lakes. Simple things: protecting shallow spawning grounds, limiting unnecessary drum harvesting, letting an overlooked native fish do the work. Early results were promising, though scientists were careful not to call it a permanent fix. Zebra mussels were still present, still spreading in some regions. But for the first time in over a decade, Canada had a natural ally instead of just a costly enemy. A rancher who had once given up swimming near his own dock said he waded in again for the first time in years. He said the rocks felt smoother under his feet. Daniel Osei still visits Lake Winnipeg every summer. He says the biggest lesson wasn't about mussels or fish or even money. It was a reminder that nature often carries its own answers quietly, long before anyone thinks to look for them. Sometimes the solution to a $400 million problem isn't a new invention. It's something that was already swimming beneath the surface, waiting to be noticed. If this story made you see freshwater lakes differently, subscribe for more true stories of nature's hidden battles and the unexpected creatures that win them.